the goal has always been to provide energy for everyone. You see, if we think about all the needs in the world, at the heart of all of them is low-cost energy, and specifically low-cost electricity. You want to solve the health crisis? You need energy. You want to solve food problems? You need to be able to power the instruments and machines and industry that we rely on.
Australia is the 9th best country in the world for creating intellectual property. It's the 40th best in the world at turning that intellectual property into companies. It's the 91st most complex GDP in the world. What that tells you is we're a very wealthy country that creates a lot of tax that goes into the academic infrastructure to make incredible technologies, but we stop there. We can't just have technologies and ideas sitting in universities. How do we actually work on companies that can ultimately make a long-term impact and generate tens of thousands of jobs, and keeping intellectual property at home in Australia? And so I met Paul 8 years ago, and his vision and the technologies that he creates do indeed have an opportunity to change the world.
We started with a single summer student and not a single experiment worked. But we persisted.
Our mission is to be able to provide a fully sustainable energy technology to the entire world. What that means is we're actually able to help the people, the 800 million people that don't have access to secure energy currently, or the people that don't have access to clean fuels for cooking. It will require a complete rebuild of both our material and energy systems. This is a silicon-based solar panel, and it has been the bedrock of our energy transition for the last decade and will continue to do so well into the future. However, it does have some limitations. Firstly, it's relatively heavy, at roughly 20 kilos per square meter. Also, it's extremely rigid. You can't bend or put this on any curved or flexible structure.
Printed solar is an entirely different way to think about energy generation.
Is lightweight, flexible, and weighs less than 300 grams per square meter. Imagine that, the difference between 20 kilos and 300 grams. But on top of that, importantly, printed solar is 100% recyclable. We can simply wash the ink off and start again. By contrast, conventional solar cells can't be recycled. There's no pathway to recycling them. And indeed, we're faced with an ever-increasing environmental hazard associated with trying to dispose of all of the silicon panels that we've already generated, let alone all of those that we're foreshadowed to need.
When we talk to many people in the solar energy industry, they ask us one question: what is the efficiency? It's an entirely different way to think about energy, and in fact, not to get so hung up about efficiency, because this can work in lower light.
How long does the technology last? What's its lifetime? And how much does it cost? And all three of those are critically important. They form like a triangle of key parameters.
Albeit this is not as efficient as a standard or conventional solar cell. But importantly for us, it's extremely low cost. It's about 1/10 the cost to manufacture than what a standard silicon solar cell is.
Which means that we don't need it to be very efficient or last very long. By contrast, conventional silicon panels are very expensive, so you need to have much higher efficiencies and longer lifetimes. In the case of printed solar, the first obvious target are all those acres and acres of lightweight industrial roofs, the sort of warehouses that you see in industrial parks, that are too lightweight to take the weight of a standard silicon panel.
Imagine this is your printed solar. That's 100 square meters of solar panel that can be covered over that roof. But what's the efficiency? The efficiency doesn't matter. So the Hunter region has a tradition in the world of energy. It just so happens to be in coal. It's the largest coal exporter in the world. But the Hunter could be a beacon of hope for the world as we transition from fossil fuel to green energy.
We're going to need all sorts of sources of renewable energy technology, be that solar, be that wind, be that tidal.
The journey we're on over the next 2 years is actually codifying all of that knowledge into a single process, where we have raw input materials being simply PET plastic or old Coke bottles, and out the other side can come printed solar, ready to be deployed anywhere and everywhere. So the journey we're currently on here at Kardinia Energy is building the first commercial scale manufacturing facility for printed solar, right here in the Hunter. And so I envision a world where we can modularize this technology, for instance, into a shipping container, where you could simply ship a manufacturing facility to all parts of the world for disaster relief, for refugee camps, and even for our own domestic use.
So Kardinia Energy's printed solar technology is arguably the only truly sustainable renewable energy technology there is. It's what's driven both of us for the last 3 years to create a business and a technology that literally we believe will save the world.
This isn't just an idea now, this is 3 years of thousands of conversations right around the world. And now it's a case of action. Now it's a case of turning those conversations, those discussions into a real impact product that can change the world.